This integral will help you get matured. So basically, while solving this integral, I'll be giving you a general idea or a general technique or behavior you will use for solving these integrals involving sine and rational functions and something of that kind. So first of all, let's simplify this by multiplying both numerator and denominator by x. Yeah, integral from 0 to infinity sine x, and then multiplied by x. By over here it will be x square plus 1 dx. Now how do we further simplify this? Okay, so most of the time if there's such expression like 1 plus y, something like that, you can basically try to change sine x in terms of the Euler's formula. That means e to the power ix minus e to the power minus ix by 2. And since it's easier to deal with e than sine, so basically you will get some ways to play around with e and the polynomials, and this will simplify it to some expressions, maybe gamma or beta or any other digamma, and you will be able to solve it. And but for this case it will be troublesome, and we have an other idea too. In order to simplify sine into some other like simpler expressions, you can also try to take the Laplace transform of this expression. So basically, if you try to take the Laplace transform of, let's say, sine of a t and take it to the world of s, this will basically just be a by s square plus a square. Yeah, and in this way also it changes to a polynomial, and only we have all the polynomials, and that will be easier to deal with. So these are two ways in which you can simplify the sine that comes in an integral. Yeah, and okay, so let's do it. So basically now we will write this as I of a is equals to integral from 0 to infinity sine of ax x by x square plus 1 dx. Yeah, now let us try to take the Laplace transform. So if you try to take the Laplace transform of this I of a, so basically this will just be applied to the sine only. Let's see how. So the Laplace transform is defined as integral from 0 to infinity of e to the power minus st, yeah, and because this is in the world of a, e to the power minus st sa, and then f of a and then dA. Yeah, and now here a is also a variable, and now after this we know that f of a is just integral from 0 to infinity e to the power minus sa, and f of a is basically, I mean by f of a I mean I of a actually. Yeah, basically let's I can write this, I can let this to be f of a as well. It doesn't really matter. Yeah, and then f of a is integral from 0 to infinity sine of a of x by x square plus 1 dx dA. Okay, and now let us try to change the order of integrals. Also take this inside, change the order of integrals. So integral from 0 to infinity, integral from 0 to infinity, I basically swapped these two. Yeah, also I'm going to swap these differentials, and this gives me e to the power minus sa sine of ax x by x square plus 1 and then dA dx. Yeah, now since the inside integral in terms of a, you can take the x's outside, x by x square plus 1, and the integral from 0 to infinity e to the power minus sa sine of ax, yeah, and then dA and dx. Note that x is just a constant while dealing with this thing. Yeah, and a is our variable, x is a constant, and if we have a sine of at, where t is the variable, a is the constant, it will be a by s cos a square. Yeah? Please note that. And please also note that we could have directly taken the Laplace transform of the sine x only. I just wanted to show you like how does that work, and so we got over here. And basically now we will just be taking the Laplace transform of sine ax itself. Others won't really matter. And so integral from 0 to infinity. We have now x by x square plus 1, and then over here, as x is a constant, so x by x square plus s square. Yeah, and then dx. And this was from the formula of the Laplace transform of sine x. Yeah, you can grab this easily. Yeah. You also, Black Pen Red Pen has a video on this Laplace transform marathon that can help you get started in Laplace transform as well if you haven't really done. Now after this, has become really easy. Also note that this is the Laplace transform of the I of a, yeah, and in the world of S. Yeah. Okay. Now we have x square by x square plus 1, and then x square plus s square, and dx. Now you can just use the partial fractions. Yeah. This will be integral from 0 to infinity. Okay, so x square plus 1. For this one, substitute minus 1 in place of x square. Minus 1. This is known as cover-up rule, and I want you to search it up yourself. Basically, if we are taking x square plus 1, we need minus 1 for x square to become at 0. So that's why substitute x square as minus 1 by s square minus 1. You can search this as cover-up rule, and you will get this in internet. Cover-up rule. And then plus, now x square plus s square. Now here we need minus s square to become 0. Substitute minus s square to all the other terms. Minus s square by 1 minus s square dx. Nice. Now after this, we know that, let's try to simplify this expression. This is 1 by 1 minus s square basically, and if I take the minus out here, this is s square by 1 minus s square, x square plus s square dx. Yeah. And now let's take 1 by 1 minus s square outside. That gives integral from 0 to infinity. 1 by x square plus 1, x square plus 1 minus s square by x square plus s square dx. Now it's easy to like integrate this thing. We have 1 by 1 minus s square. This is just tan inverse x minus this is s square, and then 1 by s tan inverse x by s. Yeah. And this is from 0 to infinity. So we get 1 by 1 minus s square. So it's pi by 2 minus s pi by 2, and then minus, this is 0 minus 0. Yeah. So what do we get? We get pi by 2, 1 minus s by 1 minus s square. So that's just pi by 2 by 1 plus s. You can write this as pi by 2 times 1 by 1 plus s. Yeah. Okay, now fine. Now we know that this is actually the Laplace transform of I of a to the world of s. Now let us take the Laplace inverse transform. If we take the Laplace inverse transform, we will again get the I of a from this expression. Yeah. And what is the Laplace inverse transform of this expression? Pi by 2 by 1 plus s, and then over here to the world of a again. So basically, Laplace inverse transform of 1 by s is just 1. Yeah, Laplace inverse, And if there's some constant, let's say s plus k, Laplace inverse will be just multiplied by e to the power minus k, in minus k times k. That will be the case. Yeah. Basically, whenever there's anything added to s, there's just this factor coming out. That's the rule in Laplace inverse transform. So you get I of k, a is equals to, over here pi by 2 is a constant, can be taken out, constant, and this will be e to the power minus k is just 1, so e to the power minus a. So this is the I of a that we have been looking for till now, pi by 2 to the power a, and that solves the integral. But no, we still have something to do. We know that this general integral is now equal to pi by 2 e to the power a. It was that what we were looking for? No, we were looking for this special case when a was equal to 1. And if we put a as a 1, we get pi by 2e, and that is the answer. And note that like how easy and simplified it became after taking the Laplace transform. Yeah, and at last you also take Laplace inverse transform. These formulas are basically dealt in other videos in YouTube, which you can check. And also, like one of the cool ways Laplace transform is used to solve integrals is also through mass identity. I want you to look into this, which I have already called in my channel. So this is also a cool way Laplace transform can be used. Basically, if we have integral from 0 to infinity sin x by x, in such cases you can take Laplace transform of one of them and inverse Laplace of another, so that if the limit is from 0 to infinity, and in that way Laplace transform will be 1 by s square plus 1, and over here that will just be 1 and then ds. Now this is just tan inverse s from 0 to pi by 2, 0 to infinity, and answer is pi by 2. So see, some integrals become really simple with some special cases of Laplace transform like mass identity. Yeah, so this also shows how helpful it can be, and the example that I did also showed that it can simplify the sign expressions and other expressions as well. And also you get the idea that whenever there is sign, you can either use any of these techniques to simplify. And yeah, I think this did make you some, give you some maturity, I guess. Yeah. Hope you enjoyed the video, and do use such techniques in the upcoming problem solving journey of yours, and hope this helps you. Yeah, so we got the answer pi by 2 e, and the flow was Laplace transform, and this was just some derivation of why Laplace transform could be done in the inside this function directly, though I showed why. And then we use partial fractions, we use the standard integrals of tan, and we took Laplace inverse, and we got the answer. So that was it. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.